In this video, we're going to look at stratified or stratified sampling. I'm going to call it stratified as I find it easier to say. I'm going to start off by looking at a sports club. I'm going to take the sports club and split it up into age categories. So we could have, for example, children. So children. Let's have juniors. So we can have juniors. Let's go for adults. So adults. And then we will have now OAPs. So let's put in OAPs. We might have 100 children, 250 juniors, 450 adults, and 200 OAPs. I might want to collect information about the people in the sports club. A stratified sample allows us to get a sample that is representative of the population, as it takes now a proportional amount from each of these groups. We call these groups layers or strata. When we're talking about it being proportional, if I wanted, for example, to take a survey or do a sample of 50 people from here, and I chose them all to be children, that wouldn't be representative. A stratified sample allows us to get a proportional representation of each of these. So, how many people have I got here? Well, let's have a look. I've got 100, 350, 800, 1000. Let's say that I wanted now a sample of 50 people from the sports club. So I want to take a sample. Now, in a question, you would read this as it's stratified. So a stratified or stratified sample of 50 people by age category. So that might be the manager of a sports club wants to take a sample stratified by age of 50 people. All we need to do is consider now the population. So in my workings, I would show 100 plus 250 plus 450 plus 200. That's going to give me 1000. At this stage, all I'm going to do is consider how many I need from each layer. So what I need is 50 of the 1000. I'm then going to multiply this by the layer size, and that's going to give me 50 over 1000 multiplied by 100. If you wanted, you could write this as a simplified fraction. That's going to be 1 over 20 multiplied by 100, so 1/20th of 100, and that gives us 5. It's clear to see that if we've got 100 people out of 1000 and we need a sample of 50, we're going to have 5. Let's now look at the juniors. What I'm going to do is use 1/20th. You're more than welcome to use 50 over 1000. I'm going to multiply that by 250. That's going to give me a total of 12.5. Now I can't have 12.5 people as they have discrete values, so either 12 or 13, and we're going to come back to that shortly. What I'm going to have now is the adults. If we look at the adults, we're going to have 1 over 20, let's write that in, 1 over 20 multiplied by 450, and this is going to give me 22.5. If I then consider the OAPs, we're going to have 1/20th of 200, and we can see clearly that's going to give us now 10. Okay, if I rounded these up, we would end up now with 5, 13, 23, and 10. If I look at that, 5 plus 13 plus 23 plus 10 is going to be equal now to 51. I need a sample that is of size 50. So what I've got to consider now is rounding these accordingly. I'm going to round this one down and I'm going to round this one up, purely based on the layer size. So what I'm going to say then is from these that I need 5, so putting this in, I want 5 of these, I want 12 of these, I want 23 of these, and I want 10 of these. So in here, I'm just going to give my final answer, and we're going to write down that that is what we need. So we can say children, we have 5 children. Juniors, we're going to have 12 juniors. We're going to have now adults, that will be 23, and then we're going to have OAPs, which is going to be 10. I can now carry out a random sample of 5 children, 12 juniors, 23 adults, and 10 OAPs. So that is stratified sampling. It's proportional or representative of each of these particular layers within the population. So let's go ahead and do a couple of questions. So what we'll look at are typical exam style questions. So here's one. A company wants to form a stratified sample to discuss issues with the staff. So we've got now the type of worker, managers, supervisors, admin, manual and delivery, and the number employed. In part A, it says how many of each type of employee should be included in a sample of size 20. So the first thing I'm going to do is go ahead and add these up. So 28, 40, 180, 210. So we've got 210. We need a sample size of 20. So what I'm going to do is first look at the managers. We're going to have 20 over 210. So it's 20 of 210 multiplied now by 8. If you want, you can go ahead and write that as 2 over 21. We're going to need a calculator, but if you want to, that's more than acceptable to do that. 20 of the 210 multiplied now by 20. If we now look at the admin, we're going to have on admin, we will have 20 of the 210 multiplied by the layer size, and that's going to give us 12. So manual, and I'll put this as MS as we've already got M, we've got 20 of 210 multiplied by 140, and finally the delivery staff, we're going to have 20 of 210 multiplied now by 30. So we've got 30 delivery staff. What I'm going to do is work each of these out. What we can see is that this gives rise to a very, very straightforward calculation. We take the sample size, so in general it's the sample size divided by the population, so the population multiplied by the layer size. So multiplied by layer size or the amount in each category. So let's just write this down, and that now is what you're going to use on each of these. So now we've put it formally, that will work for all of these. So let's grab up the calculator, and what I'm going to have is now 20, so I'll do it as 2 over 21 to make my life slightly easier in here, and I'm going to multiply that by 8. This is going to give us a decimal answer, and that's 0.761 and so on and so forth. 0.761 ... Okay, let's now do this, and we will swap this over and just plug in that in, we'll make that 20. So if we do that, we've got now 1.904, so 1.904 ... On the next one, I'm going to switch this over and make this now 12, so let's put in 12. So that gives me 8 over 7, which is 1.14, so 1.14 ... and so on and so forth. If we look at the next one, let's just put in 2 here. Let's go ahead and put in the next one. We're going to have 140. So now let's go, let's just grab that up. We want that one. So let's put this in. So 2 over 21. So 2 over 21. And we're going to multiply that by the 140. So 140. And that now is going to give me 40 over 3, which is 13.3 recurring, so 13.33, ... and so on and so forth. And then we'll just go for the last one, which is going to be 30, so let's just plug that in there. So put in 30 in. That gives me 20 over 7, which is 2.857, and so on and so forth. So 2.857 ... Okay, so these are what my calculations have said. Now, if we look at this, I've got the choice here. We could round all of these up. The issue is, if I round them all up, we need a sample size of 20. So if I rounded this one up, I'd have now 1, 2, I'd have 2, I'd have 14, and then I'd end up with this one with 3. We can clearly see this is going to be too many. So instead, what I'm going to do is round this one to 1, I'm going to round this one to 2, I'm going to round this one to 1, this one now to 13, and I'm going to round this one to 3. There will be some leeway, but you must ensure that you have 20 in total. So that's 4, 17, 20. So what I'm going to say then is that M, we're going to have 1. For S, we're going to have 2. For A, we're going to have 1. For MS, we're going to have 13. And then for D, we're going to have 3. And that gives me a sample size of 20. And I can go ahead and carry out a random sample with one person from the managers. We can have 2 people from supervisors. We can have now one person from admin, and so on and so forth. As stated, there will be some scope for rounding these numbers. Let's now look at part B. It says if a stratified sample contains 8 manual staff, what would be the size of a complete sample? A few different ways to do this. If we look, the manual staff are 140 out of 210. So if we look at 140 of 210, that is going to simplify, the zeros will cancel, 14 divided by 21 will give us 2/3. So what we could say here is 2/3 are, and writing this in, 2/3 are manual staff, and that is equal to 8. Therefore, we would have now 12 in the sample. 8 is equal to 2/3 of the sample. So 12 in sample as 8 is equal to 2/3 of the sample. So that's one way of doing it. That's fairly sort of manual. If you wanted another way, we would take x of the 210 and multiply it by 140. So x being the number of people in the sample, and that gave us 8. So if we simplify this, 2/3 of x is equal to 8. So if we multiply both sides by 3, divide by 2, x is going to be equal to 12. So that's another way. Plenty of different ways that you could do that, but we can see now that the manual staff are 2/3 of the total, therefore 2/3 of the sample size that we need. If 8 is 2/3, then 12 is that sample size. Okay, let's move on to another question. So this one says, in order to form a sample, a number of pupils are selected from a number of different teaching groups. So these are the layers or the strata. The size of the samples and the teaching groups are given in the table below. So A, we've got now 36 in the group, we've got 9 in the sample. B, 32 and 8, C, 24 and 5, D, 18 and 4. So what we are to do in part A is say, is this a stratified sample? If it is, what we're going to have now is that these are going to be representative of each category, and they're going to have the same ratio or the same fraction. So 9 over 36 breaks down, I'm just writing this in, 9 over 36 is going to be 1/4. 8 over 32 is also 1/4. If we look, 5 over 24 is not 1/4, and 4 over 18 is also not 1/4. So what we could write here is it's not 1/4. This is one way of doing it. So writing it down. So what we'd have to do is have all of these that are going to be representative. Now, if this was 6 and this was 24, that would be 1/4 and it would be representative. You could argue on this one just here now that there's some scope to move, but it's this one that I'm interested in. So what I'm going to say now, in part A, we can see if stratified, let's write this, if stratified sample, and just jotting this down, we can say that the group C, if stratified sample, group C, and just jotting it in, group C would have, so would have now on here, let's write it in, 6 people, for example. And this is just one of the many choices. You've got 6 people, for example. Let's put that in. So if we wanted to be in keeping with these two, then this one would have to be 6, and that's not the case. Okay, so now in part B it says, how should it be changed to give a stratified sample? So what we'll do is keep these ones, and then we will alter these. So in part B, I'm going to say that we're going to have now 6 people. So 6 people from group C. So 6 people from group C. So from group C, and just jotting this in. If we look at this one, we need 1/4. Now, just considering what we're going to have here, 1/4 is going to give us 4.5. So I'm going to say that we'd have 5 people. So 5 people from group D. So just writing this in, group D. So that would give me now a stratified sample. It's just one of the things that we could do. So all I'd say is I wanted 6 people if we're going to keep in it with 1/4, and then I would change this and I would round it up. We could say 1/4, and just put in this here, 1/4 of 18 is going to be equal to 4.5. Therefore, we're going to have now 5 people. So that's one possibility for you. So there we go, stratified sampling or stratified sampling. What we're looking at doing is finding now a representative sample. It's proportional to the layer or strata size. We take the sample size divided by the population and multiply it by the layer size, or the number in each category.